Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing processes, and we are talking about the techniques, methods and fundamentals used for improving the properties of the surface. This is the new presentation, new topic for us. So basically the topic is surface properties improvement. We know that most of the mechanical engineering components during the service interacts either with the environmental conditions in which they operate, or they interact with other metallic or materials components. So because of these environmental exposure of the service, or when they are meeting or in contact with the other components, or when they are subjected to the tensile loading, when they are subjected to the fatigue loading, so most of the mechanical components tend to fail from the surfaces, from the surface. So the component which is interacting with the environment or with the other material component, these surfaces will be interacting. So these surfaces, when they interact or they work in environmental conditions, they lead to the degradation during the service, and this degradation, the approach or the mechanism of the degradation will depend upon the kind of the service conditions which are being experienced by the material or by the surface. So in order to improve the performance of these mechanical component, efforts are made to improve the properties of the functional surfaces, means those surfaces which will be exposed to the environmental conditions, or which will be interacting with the other matting component or other mediums in which they are operating. So basically the target is that functional surfaces of the component, properties of the functional surfaces of the component is improved, so that they can really perform for long. So the target in this approach, which is called surface modification, and more broadly it is called surface engineering, wherein mainly the focus is on the improving the properties of the surfaces. So that so the surface engineering, basically it is about the engineering or governing or regulating the surface characteristic. So it is defined as, or we can say, if you have to understand, the surface engineering is an approach or broader area wherein approach for developing the surfaces which are actually different from the which are having the characteristics different from the substrate or the base material. So this base material or the is also termed as substrate in the surface engineering. So the properties of the surfaces are different from the substrate or the base material, so that the purpose of developing such kind of the surface characteristics on the substrate is to increase the life of the component which is working, and also increase the functionality, means the conditions under which it has been working, even if they are more severe, they can sustain those conditions more effectively and work for longer period without failure. So which in turn improves the reliability of the component and increased availability. So in surface engineering, basically the focus is on improving the surface characteristics, so the functionality, the properties of the surfaces and the life of the component can be improved. So there are various properties which are important, and there are various purposes which are achieved through the surface modification or through surface engineering. Main target is to improve the wear resistance, which can occur through the different mechanisms like abrasion, which is normally experienced while handling with the hard materials like excavation, mining, and then in cement industry, then adhesion, wherever the metal to metal contact and relative motion exist in, like piston and cylinders, and guideways and the carriage, So those kind of relationship. Then erosion, which is experienced like in it may be like hydro turbines, which will be experiencing either erosion due to the sand particles or due to the cavitation. And then corrosion is also another form where in chemical interactions between the environment and the surfaces will be leading to the loss of material. So efforts are made to have the properties at the surface which can resist these commonly encountered the wear mechanisms. Another is to improve the mechanical properties so that the component can take and sustain the loads, service loads more effectively. For this purpose, like increasing the hardness, increasing the toughness at the surface, improving the work hardening behavior. So these are some of the things which are expected so that the component can survive and sustain the real service conditions more effectively. Then improving the lubrication behavior at the surfaces and reducing the friction behavior when interaction between the metallic components is taking place. So increasing the lubrication, reducing the friction coefficient and the frictional conditions which will be existing between the interacting surfaces. Then another purpose is to improve the aesthetics of the components so that they look good, aesthetics of the surfaces. So they look good. For this, basically the coatings of the nickel and chromium are commonly applied, so they look smoother, better in appearance for improving the surface characteristics. So these are some of the properties. Apart from this, there can be this list can be very wide, like improving the electrical properties, improved electrical conductivity or increased electrical insulation. There can be the purpose of increasing the thermal insulation, if you want to improve the thermal efficiency of the heat engines or other thermal based systems where we do not want the losses of the heat from the engines and from the turbines. So their thermal insulation helps to improve the thermal efficiency of such kind of the system. So these are some of the characteristics or some of the purposes for which the surfaces are modified in order to have the better surface properties, improved functionality and improved life of the components. Now, so what are the mechanisms which are normally used for improving the mechanical properties, so which in turn will be leading to the improved wear resistance. So if we see in the surface modification or in the surface engineering, some of the approaches for improving the mechanical properties and improving the wear resistance, some of the things which are kept in mind are there is very wide range of the processes and approaches which are used for the surface modification, so that the wear resistance and the mechanical properties of the surfaces can be improved. But still there are some common approaches which are there. One is like the work hardening through the controlled plastic deformation, at the surface. This is one of the approach which is used. In this case, there is no chemical modification, there is no other structural transformation. Most of the time there is no structural transformation. However, in case of the steels it may occur. But mainly the efforts are made to have the work hardening effect through controlled plastic deformation at the surface and near surface layers, so that performance can be enhanced. Another one is the grain refinement in some of the systems like austenitic stainless steel and the aluminum alloys which are non-heat treatable. The grain structure is refined. So for this refinement, the thermal as well as mechanical methods can be used. We know that as soon as the average grain diameter is reduced, there is a improvement in the hardness and increase in the yield strength of the material. So the near surface layers grain structure is more refined in this approach, so that improvement in yield strength and the hardness can be realized. Another one which is very commonly used is the transformation hardening. In the case of the transformation hardening, the surface layers, such kind of the structures are formed which are really hard, like martensite and the benite. So hard and strong structures are formed at the surfaces through the thermal treatments, in mostly in case of the steel, so that the surface properties get improved. Then there is another approach where in chemistry is modified, chemistry at the surface is modified. So whenever the chemistry modification takes place, there will be formation of the new phases, and there may be the form, and these phases will be leading to the improved hardness, improved strength, for improved wear resistance and the mechanical performance. So there are so many methods wherein chemistry is modified at the surface, like carbon concentration is increased, nitrogen concentration is increased, boron and vanadium is increased. And then there is one more approach wherein the surface layers are deposited at the surface. So in this one we try to bring in altogether different kind of the material at the surface, so that it will have the different properties as compared to the substrate material. So these are the some of the approaches which are used for surface modification, so that improved wear resistance and improved mechanical properties can be achieved. Now we will be looking into the properties really that are important from the performance point of view. So these properties can be grouped into the four headings, like the physical properties, chemical properties, mechanical properties, and the dimensional properties. These are the properties which are important from the performance point of view of the surface modified components. So among the physical properties, like it may be thermal conductivity, or if you will see opposite of this or inverse of the K, then it is thermal resistivity or thermal insulation. Then electrical conductivity, which is electrical resistivity is rho, so this also indicates the electrical conductivity. Then the thermal expansion coefficient, then the melting point. All these things actually matter in sustaining the surface material for under the service conditions, and so that the desired functional properties of the surfaces can be offered for the given purpose, so that the component can perform for long. Then the chemical properties, among the chemical properties we have like affinity to the atmospheric gases, whether the surface interacts with the surrounding, like if there is a moisture or there is a atmospheric air or the steam. So interaction of the metallic component with the surfaces can lead to the degradation, can lead to the formation of the compounds and corrosion, oxidation. So these are the some of the ways by some of the characteristics related to the chemical properties which will be important from the performance and the functional performance of the component. Then there is like other things which are which also affect the performance of the component, is the solubility of the metal to the gases in liquid and solid state. Sometimes this leads to the issues like the formation of the pores and formation of the cracks due to the hydrogen induced cracking or the cold cracking. The performance of the surfaces and their ability to interact with the external conditions to a great extent depends upon the mechanical properties like hardness, tensile strength, which is mainly checked depending upon the condition. It may be ultimate strength or the yield strength, then the ductility, toughness, fracture toughness, which shows that how much resistance it will be offering against the crack propagation or for fracture, and then fatigue resistance. So all these characteristics will be affecting of the all these characteristics of the functional surfaces will be affecting the ability of the mechanical component to sustain under the service conditions significantly. Among the dimensional properties, these are like straightness, flatness, and then roughness, like smoothness of the surface in terms of the RA, that is the surface rough center line average value in micrometer. Then for the cylindrical component, it is the cylindricity, circularity, etc. will be affecting the the functionality of the component and ability to work under the real service conditions for long. So means the functionality as well as the life of the component to a great extent is influenced by these physical, chemical, mechanical and dimensional properties. So as per the requirement of the functional properties of the surface for prolonged service, the suitable characteristics are designed so that the component really can perform for long. Like say component A is expected to perform under certain conditions of the load, velocity, temperature, pressure, environment. So to survive this component under these conditions, it is necessary that it has a certain set of the chemical, physical, mechanical properties and the dimensional properties. So for that purpose, its proper surface properties must be engineered from all around the surface. So the surface of the substrate component has the requisite set of the properties, while the substrate itself may have the different set of the properties, and therefore to modify the surface properties we need to apply some of the surface engineering approaches, some of the surface modification techniques. So entire group of the surface modification techniques can be classified in a certain way. For that what we can see, so in order to classify the entire range of the surface modification approaches, like surface modification broadly can be grouped under the two headings, wherein there is a change in surface layer of the component, like this. So the surface layer itself is modified, surface and below surface layers are modified. Another approach is that build up of a layer, wherein the component to be modified remains same, but the additional layer of the material which will be having the suitable set of the properties is applied on the surface. So this is where additional layer is built up. So change in the surface properties can happen in the two ways. In one category, wherein there is no change in chemical composition or chemistry doesn't change, and where another one, chemistry or chemical composition is modified. So in this category, wherein there is no change in chemical composition, still we have the two broad approaches at the surface. So say this is where the chemistry change doesn't take place. So there are two approaches. One is the surface layer deformation, and in the second, surface layers subjected to the transformation of phases. or grain structure modified. So basically microstructure modification is realized in the second group. So if we see this one, just near surface layers will be subjected to the plastic deformation, so that work hardening effect is realized and the surface gets strengthened and hardened to take up the more surface loads effectively. And under this category there are a few methods like shot peening, burnishing, and sandblasting. Or shot blasting. Then under the second category, surface layer transformation is achieved without any change in chemical composition. In this approach, basically using the thermal methods, the heat is applied just near the surface layers. So either a structure gets transformed into some harder phases or a structure gets refined. So there are two approaches, one where phase transformation is realized, like martensite is formed or benite is formed intentionally, or the second approach here is like there is may not be any phase transformation, but if the structure in the beginning of the bulk material or means of the substrate is coarse, then through the controlled application of the heat, near surface layers are refined significantly. So this refinement will be causing the grain refinement hardening or grain refinement strengthening. So another approach is grain refinement. So those systems like maybe non-heat treatable aluminum alloys, they can be strengthened through this kind of approach, or wherever like the conditions are favorable for the grain refinement, that will be leading to the improvement in the mechanical properties irrespective of the phase system. So here maybe alpha, beta or whatever phases are present, their average size is reduced in these methods. So in this category there are few methods which can be mentioned here as which will be using the phase transformation or the grain refinement without change in chemical composition. So surface transformation or grain refinement. In this one we have the common methods like laser hardening, or similarly electron beam hardening can also be used. Then the plasma arc hardening is carried out, PA hardening, where then there is the flame and induction hardening, means the current is induced and surface layers get hardened, the flame hardening. So these are the methods wherein either just like the phase transformation is facilitates the grain refinement of the grain structure, or either phase transformation or the grain refinement facilitates the grain structure. We will be talking about these techniques in detail subsequently. Now we will talk about the another group of the processes where chemistry is modified. So in another approach where in chemistry is modified, there are like different mechanisms which help in realizing this. One is where chemical modification through diffusion. The second one is where the melting facilitates the modification of the chemical composition or the chemistry of the functional surfaces. And then there is a hot dipping, like in hot molten bath the component to be surface modified is dipped into, and then electrolysis based methods, based methods, and then we will have the mechanical methods in mechanical methods. So here where the surface chemistry is modified, means altogether different material system will be having. So typically if under this category what we will be having like in the diffusion, like some of the methods where in like carbon, nitrogen, vanadium, boron etc. at the surface is induced through the diffusion. For example, this is the component to be surface engineered. So suitable rich environment, for example either carbon or the nitrogen or boron or vanadium, rich environment is created around the component at high temperature. So because of the concentration gradient, carbon or nitrogen or boron starts getting diffused into the component. So depending upon the depth up to which we want to modify the surfaces, this is continued, and once we have, then suitable heat treatment may be undertaken in order to form the phases that are required, so that required set of the properties can be obtained. For example, if we are introducing carbon, commonly known as a carburizing process, so here the carbon is enriched, but just enriching carbon may not help to increase the hardness. So we need the heat treatment for martensitic transformation purpose, so surface layer can be hardened, otherwise it can simply form iron carbide or carbides, other carbides. Similarly, the iron nitride is also formed at the surface for increasing the hardness of the surface. So in all these methods, if we see, we will go through the typical names which are used for modification of the surface composition through the introduction of the carbon, nitrogen, vanadium and boron. So we will see here the diffusion based processes are like carburizing, wherein carbon is introduced at the surface, then nitriding where nitrogen is introduced, then vanadizing, vanadium is introduced, and boronizing, boron is introduced. So the formation of these compounds will be leading to the improved surface hardness and improved surface properties. So these are the this is one of the classification now which is primarily diffusion based processes to modify the surface composition. In other group of the processes like melting, hot dipping, electrolysis and the chemical methods, some kind of the layer at the surface is developed. So say in case of the melting, the surface base metal is melted and coating the material to be applied is also melted. So some kind of the layer is built up, so that the rest of the methods we can club under this category, build up of layer for the melting, hot dipping, electrolysis and the mechanical methods. Details of these methods I will talk in the subsequent presentation. Now I will summarize this presentation. In this presentation I have talked about the importance of the surface engineering and what are the broader approaches which can be used for modifying the surface properties. Thank you for your attention.